Hello, everyone. Thank you for joining our live session today, and welcome to the second session in the Python and Agent series. My name is Larissa. I'm an event planner at Reactor, joining you from Brazil. Before we start, I have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. The session is being recorded and will be available to view on demand here on the Reactor YouTube channel within 48 hours. Keep an eye on the chat. We'll be dropping helpful links and checking for questions for our presenters to answer. I'll now turn it over to our speaker for today. Thank you and welcome, Pamela.
Hello. Welcome everyone to our Python plus Agent series. This is a 6-part series where we are learning how to build agents using the Microsoft Agent Framework. So we're doing this series over 2 weeks. If you haven't registered yet, you can still register, and that way you'll get emails and notifications about the upcoming sessions and links afterwards for them. We are in the second session of the series, so we still have lots to learn. So for today's topic, we are going to discuss how we can add context and memory to our agents, which is going to make them more powerful and smarter because they're remembering things and more capable. So we're going to be talking about, first, what is this word context? It means a lot of things in a lot of situations. It is context dependent. That's a joke someone came up with in our office hours yesterday. So we're going to talk about that generally. We're going to dig into memory, different kinds of memory, and then talk about knowledge providers for RAG, and then go over context management techniques. We do have a lot to cover today. It is going to be jam-packed, and we're going to try and squeeze it all in. If there are questions that we don't answer during the session, we do have office hours right after in the Discord. So please, save your, any questions that don't get answered in the chat, save them for office hours and we'll answer them there. So if you'd like to follow along, we have created this repo that has all the examples, and the majority of them you can run for free in GitHub Codespaces. So what you want to do is visit this repo, and we're going to put this URL in the chat and in the banner so you can go get to this URL. So you're going to go to this repo here, and you're going to create a GitHub Codespace. So I'll show you what that looks like. When you're over here, you're going to click on the code button, and then you're going to see a big old mount. I don't have the button here because I already made my code space, but you'll see a big button here that says create code space on main, and you're going to click that and make the code space. And that is going to open up a browser tab with a VS Code in the browser that has all the files and the environment set up. Now, if you already, actually for everyone, I'm going to recommend that once the code space starts up and everything's looking good, I do want you to run git pull just to make sure that you have the very latest changes. I already ran it here, so it got it. We noticed that the code space is it's like a little out of date. It's got some of the older files, and we did make a few improvements to today's examples. So once you have it all started, just run that git pull just to make sure you have the very latest files, right? So here's our instructions. You're going to open the repo, create a code space, wait a few minutes for it to start up, and then git pull to get the latest changes. All right, and if you have any issues or questions with that, do post in the chat, and hopefully my colleague Gwen can help out with technical problems. You can also do it locally, but if you do it locally, you're going to have to read that README in order to configure connections to models. So it is much easier to do it in the code space. All right, so let's get into it. We're going to start with a recap, because yesterday we talked about agents and how to build an agent. If you missed yesterday, you can still watch that later. But basically, what is an agent? It is it's an AI agent, uses an LLM to run tools in a loop in order to achieve a goal. So yesterday we saw many examples of agents using tools like local functions, also agents using tools from MCP servers, agents using 1 tool, 3 tools, 5 tools, right? And basically, the agent decides which of those tools it's going to call in order to get the answer that it needs. So that is the basic agent, and an agent on its own with the right tools is very, very powerful, right? However, what we're going to see today is that we can improve agents by giving them even more context to help them answer the questions, right? So we have different kinds of context. One kind of context is knowledge. If we're building an agent that's already operating in a certain domain, we can either give them tools for that domain, or we can just always equip them with knowledge pulled from that domain. So we're going to see today ways of providing knowledge that aren't just about tools. Then there's also memory. So giving the agent the ability to remember things that the user said before, both in the current conversation and in past conversations. So we're going to see actually 3 different kinds of memory today. And that can make the agent seem like it's learning. It's not really learning, it's remembering, but it'll feel a bit like it's learning, like at least that it's learning about you and your preferences. And that's really helpful, right? And then humans can also provide more context. We're going to talk about that more next week when we bring humans into the loop. So here we go. So what is context? And I think there's many definitions of context out here, but what I went with is that context is everything. So I say that the context to an agent is all of the inputs that help the agent decide what action it will take next and how it will respond, right? So really the context is everything getting sent to the agent, right? And everything includes a lot of different things, right? So, at the very top, we have our system prompt, right? This one is your friendly weather assistant, right? So that's like our standard system prompt, right? Then we can have environment information, right? So a really helpful thing to tell all of your agents is what is today's date. It can be so much more helpful when it knows today's date instead of thinking that the date is, whatever it was trained with, right? Like, it's training cutoff, right? So environment information, today's date is this. You are, you're on a Mac machine, right? Like whatever sort of information you can give about the environment, you can put that in there. And then domain specific knowledge, right? This is a weather assistant. It might always need to know that, oh my God, there's like a huge earthquake going on in Japan, right? Like that might be the kind of knowledge you want to just put in that initial message because it's just so relevant that it needs to always be there, right? So domain specific knowledge that you want always to be there. Then we have memories from previous conversations. Hey, by the way, the current user you're talking to lives in California, right? That's something that it learned about the user from a previous conversation, and it can use that to personalize the current conversation. Then finally, we have this that all gets stuffed into the system message, right? And then finally, it's actually the agent is having a conversation with the user, right? The user asks the question. The LLM answers, and maybe it answers with a tool call, maybe it answers with actual natural language text, and that entire conversation is also part of the context, right? So all of this information is what gets sent to the LLM and helps the LLM do a better job answering the user's questions and achieving the goal. So we're going to look at how we can provide all these kinds of context today. We're going to start with memory, which is actually it's a big topic and also has a lot of definitions. So this is the way that I like to think of memory, right? So first we have the simplest kind of memory, which is, can the LLM even remember the past messages in the thread? And this sounds simple, but it actually does require some coding in order to make sure that the LLM is seeing past messages in the thread. And that is important, right? If a user is having a conversation with the LLM, they want the LLM to know about what they've talked about in the past, right? So that's just remembering all the messages and tool calls that went out. A lot of times this is stored purely in memory, but it can also be persisted to a database as part of like a chat history. And sometimes you may want to have truncation or summarization if a thread gets really, really long, right? You're having this like hour-long conversation with the LLM and you're just giving it so much information that it can't fit it all in its context window, then you're going to have to do some truncation of that of that thread. And we will look at truncation techniques later today. The next step of memory is, can the application remember past conversations? So this isn't as much about the LLM, but this is just when you're designing a user-facing application where a user can chat with an agent. They do expect that app to have chat history, right? So that if they had a conversation yesterday, they can go back and find that conversation, and they could like renew a conversation that they were having, the week before, right? And so that kind of ties into this, is that you want to be able to like find your previous thread and then keep adding on to that thread, right? Like I've got some long running threads with like ChatGPT, where I will revisit them once a week and just add a new message to the thread, right? So these two are very much related, where you want to be able to remember a session in a chat history and then keep building on that session too. So you're going to like take it from your database, load it into memory, and keep building on it. And so that you're going to want to store in some sort of database. And then finally, the really interesting kind of memory is, can the LLM remember facts? I'll call them facts, preferences, important things from past conversations that would affect, future actions, right? So I call this dynamic memory. This would need to be stored in a persistent database because it's remembering this over time. And you often want some ability to search through the memories if you're accumulating quite a bit of memories, right? But at the very minimum, you need a way to retrieve those memories, right? So we have these three kinds of memory here. And now we're going to see how we can actually implement these three kinds of memory using Agent Framework. So first, we'll talk about the simplest, which is just remembering the current conversation, right? So here we've got the agent. The agent is answering a user's question using a bunch of tools and then coming up with a response, right? So we've got the system prompt. The user asks a question. LLM makes a tool call, gets a response. LLM makes a tool call, or LLM gives an answer. The user asks another question. We get another tool call, another response, and the LLM answers, right? So we want to store all of this in a session's memory so that the LLM remembers everything that happened, right? All the tool calls, all the responses, and all the user inquiries. So the way we can do that in Agent Framework is we're using the concept of a session. Okay, so what we do is we say, when a user is starting up a new session, we're going to use agent.createSession, and that creates a session that has a unique ID. And then whenever we run that agent with input from the user, we're just going to pass in that same session, right? So let's go ahead and try that out. So I'm going to go and open this one, agent_session, and just look down here. So this one, actually, we have a few examples in this code here. So first, we have an example without a session to prove to you that, in fact, you can do it without a session, and it's going to be weird, right? So if we just say agent.run and we do not pass in a session, and the user asks like, oh, what's the weather like in Seattle? And then asks what was the last city I asked about, the agent will have forgotten. So we can see that. Let me actually just comment out these two in comparison, so that we can see what it's like without a session and really motivate the fact that we do want to be using this concept of sessions. And this is another reason why we use agent frameworks, is that they have built in this idea of threads, sessions. Otherwise you have to code this up yourself. All right, so the user asks, what's the weather like in Seattle? This is the tool call here. And now the agent replies. The user asks, okay, what was the last city I asked about? And then the agent says, I don't see an earlier city, right? And this is a horrible user experience, right? The user is like, what the heck? What happened? You forgot, right? I've had that experience with a few agents where I'm like, oh, it's just so frustrating. So now the next thing we can do is create a session. So we're going to say create session. And now this time we're going to pass that session into both of these calls, right? So this time we should see that it is going to remember what it's talking about, right? Because here the follow-up question is, oh, how about London? And they haven't really given any context. Like it's just a follow-up question, how about London? But it's going to know that we're talking about what's the weather like, right? Because it's going to see that the previous question was about weather, right? And then I asked, oh, which of these cities has better weather? And that's really showing that it knows what we're talking about. It says, oh, both are cloudy, but Tokyo is warm, London is cool, blah, 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 right? So it definitely has seen the past history. Now, what's really interesting is that you could actually share a session across agents, right? So, the session is actually, it's a conversation history. It's not necessarily tied to the agent. So if you want, you can create a session, then create another agent, and you can pass that session to the other agent. So there is portability of sessions here. So that's this final example here. And this is also just helps you to realize that sessions can be restored, right? Sessions are portable, sessions can be restored. Once you have this concept of a session, as long as it can be serialized and deserialized, then you can restore it and use it across, multiple days and even across different agents, right? So there we go. So that is the idea of, of sessions. So that brings us to the next concept, which is persistent chat history. How does the application remember those sessions over time so the user can, find a list of their previous sessions and potentially even, keep building on a past session? So what's that going to look like? Okay, we have this session. We need a way of storing that session in a database, right? So if whatever database we pick, we're going to have to decide for that database, how are we going to identify each session? How are we going to store the messages, right? We could store the entire thread in a single row. We might split the thread up over multiple rows, depending on database constraints, right? So that's just what you have to figure out for your particular database. Like, will entire threads fit in one row? Like, what's the maximum size of your database? How do you tie the sessions to users? You want to be really careful about, user privacy and not leaking things across users and making sure, identifiers are unique. And then you also want to think about whether you're going to want to search those sessions, right? If you want to be able to search those sessions, well, then you want to stick them in a database that supports search, right? So the first example we're going to look at is a simple storage using Redis as the history storage mechanism. And this is something that actually has built-in support in agent frameworks. That's why we're starting with it. And for this, we're going to be pretty simple about it and say, here's the key. The key is just per each session, and the value is the entire list of messages. And we're storing this list type in Redis. So in order to do that, we can use the built-in history provider. That's what Agent Framework calls it, is a history provided. So we're going to use that built-in Redis history provider. We point it at our local Redis and give it a little ID, just to identify it. And then here, the crucial thing is when we make this agent, we're going to say context providers and pass in a list. And one of those providers is a history provider. Okay. So we're going to see this context provider used quite a bit over today. But this is our first time seeing it with providing the chat history. And then when we create a session, we're going to make sure that session has a unique ID so that it's unique across all of our sessions. So let's go ahead and check out that example. It is agent history /Redis. And we're going to try it out. Agent history redis.py. So I say UB run examples agent history Redis. And it's going to create the session ID, set up the context provider here with Redis provider, create that session with that session ID, pass that in to these agents. And then we also do a simulated restart where we recreate the history provider and recreate the agent and verify that we can resume it, right? So if we look back here, we say, what's the weather like? How about Paris? Okay. And then we completely restart, create a new history, a new instance of our history provider and our agents. And I say, oh, which of the cities I asked about had better weather? and it completely remembers, right? It is actually restarting that conversation, right? All we had to do was pass in the same session ID from before. So those session IDs are really important because those are being used for your history provider and are being used when you say, hey, this is the session we're using. So if you want to renew a session based off of something in your history, you want to remember that session ID. So great, it was able to resume it. We can also go ahead, I've got like a little Redis viewer script so we can see what's in our Redis database locally. And this is using a local database to clarify. So if you are in the code spaces, the code spaces should have a Redis running here, and that's because of how we set it up with this Docker Compose file. So we are running a local Redis in this case. In production, you could use like Azure Redis or another production Redis. But in this case, we are using a local Redis and storing everything there for our development needs. So we can see it found one key, which is this is the session ID for the chat history. And we can look at the values being stored in that key, just the value, right? So what we can see in that key is that it is storing the entire conversation, right? We see the user message, and at the end, we see the new message when we renewed the thread, right? So it's pretty straightforward, where the key is the session ID and the value is the entire conversation. All right, so that is the Redis example. Now, you might want to implement your own provider, right? Like maybe I'm going to show a SQLite example, but you could use Postgres, you could use Cosmos, you could use Azure SQL, right? You could use any of your favorite databases in order to store chat history. You could use local storage. I was actually doing that last night for a client-side only example, although that was not in Python. But the idea is that you could in theory use any database. So in here we're doing SQLite, right? And for SQLite, I'm going to store it a different way just to show you a different way of storage. So in this case, I'm going to actually store each message as a separate row. And this is helpful in cases where your databases have constraints on the size. For example, Cosmos DB has a constraint on the size of the documents. So whenever I store chat history in Cosmos DB, I do only store like one message per row. And then I'm going to have the thread ID be stored in a column, and then the ID is going to be increasing for each new message in the thread. So if I want to get everything in a thread, I'm going to do a select where the thread ID is this session ID. I'm going to order by ID, and then that'll get me back the entire conversation, right? So this is another way you could lay out your database schema when you're storing in a database. So in order to implement this SQLite history provider, since it is not built into Agent Framework, all I need to do is make a subclass of base history provider, which is from Agent Framework. And in that subclass, I need to implement a few methods. So let's just look at that in agent history SQLite.py. So if we go up here, we can see here is our subclass. And the first thing we do in the init is we create and connect to a SQLite database. Then if the create table if not exists, and we can see ID, session ID, and message JSON, right? So that's what we're storing in this. Then we need to implement get messages. That's required so that there's a way of getting all the messages based off session ID. So we're just doing aware and order by ID. Then we need a way of saving the messages based off a session ID and a list of messages. So we're going to insert that into messages, and this one's an insert many because it's receiving many messages. And then we need to just close the connection here. But the important thing for a history provider is get messages and save messages. So now let's try running this one. So UV run examples, agent history, SQLite.py. I see a question, how about a blob storage history provider? I've never done that myself. That would be a lot of updates to a blob unless you're doing like a new blob for every message, but that also feels like a lot of tiny little blobs. So I wouldn't inherently think that that would be the best use of blob storage, but also, maybe I don't understand like how incredibly flexible blob storage is. So I would just consider like the number of read operations and write operations you're doing and whether it's a good fit for the database. Okay, so we see it's the exact same, the user experience is the same here, right? So what's different is how it stored it. So I'll go ahead and open up my SQLite viewer. And in the SQLite viewer, we can see that this time there's actually a bunch of keys here. So let me look at a key, 6 sessions. Oh, I wonder if I didn't clear out my SQLite. Here, let me go ahead. I'm going to delete my local databases. Okay, and then I'm going to rerun the history example just to start my SQLite database from scratch. That's the nice thing about SQLite. You can just YOLO delete your database when you feel like it locally. I wouldn't do that with production. Okay, so now it's rerunning. So it should be, you can see it created the new the .SQLite 3 file, created it fresh. So we can see what it looks like just from scratch here. And I see a question, what's the difference in using a SQLite database versus a vector database like Chroma? Yeah, that's a good question. So this was my, thing about, do you want to have a search on your history provider? If you want a good search on your history provider, then you want to see like, hey, does my database support search? SQLite does have a very good full text search, but it doesn't have a good vector search last I checked. I think there's like a new community extension, but I haven't tried it yet. Obviously, Chroma has a vector search. Postgres has a fantastic vector search and a full text search, which isn't actually as good as your AI search. We're going to see that one. That one actually does have really, really good search of all kinds. So if you are going to want search, then you just need to think about what kind of search do I want to support? And does that database have that? Cosmos DB, Azure SQL, they both support hybrid search at this point. So they're good. They're good picks for it. So yeah, lots of database options. SQLite is more for development. I actually would not use it in production. I just wanted something that was easy to run locally here. So here we have, okay, so this time we see that there's one session with 10 rows, right? So each of those is a row. So now if we look, each of those is actually a row. So this is a row here. This is a row here. This is a row here. So it's being stored a little bit differently than Redis. And that's just a design decision that you're going to make when you're making your history provider. And we are going to talk a little bit about vector search when we get to knowledge. I didn't implement search on top of those memory providers, but I'm sure if you all asked like, hey, can you show us an example? We can code something up for you, maybe in office hours. All right, so that is chat history. So that is definitely something you're going to want to add to a lot of applications if they are user facing and the user's having persistent, chats over time. Now let's talk about another thing that is helpful for user facing agents, and that is dynamic memory. So the idea here is that, the agent receives an input. Based off that input, they go and retrieve relevant memories from the memory store. So they actually often will search the memory store for the most relevant memories and then give those memories to the LLM along with the user input and any other context, right? And so then it's just the LLM can make a better, do a better job deciding how to answer a question based off those retrieved memories. So you have some design questions here as well, like, are you going to retrieve all the memories? Some memory implementations will go ahead and just retrieve all the memories because they presume there's not that many. Or are you going to do a search, a filter, just to find the ones relevant to that conversation? And then there's a question of how you're going to store the memory, right? So after the LM gets a response, then that's the time at which you decide whether it's learned something from this interaction. So you have to decide, am I going to store, how often am I going to store memories? What is that memory going to look like? Am I just storing the entire conversation? Like some memories are just the whole conversation, but that's not very smart, right? Like ideally, to be really smart, you're looking at the conversation and saying, aha, I learned something new from this, something that's relevant and unique and different and surprising, and I'm going to store this new fact in the memory store, right? And then there's a question of forgetting memories, right? Do you keep all memories around forever? Do you decide some of them are obsolete at some point? Do you update the memories? Like that's a whole thing as well, right? Because facts change over time, right? Like for example, when I use ChatGPT, it thinks I have like, a 3-year-old and 6-year-old, but as soon as one of them has a birthday, that's not going to be true anymore, right? Like it has to be able to update its memories over time. So first, let's look at the simplest dynamic memory provider we have, and that is with Redis. So in this case, we are going to send the input to Redis, and that is going to use a hybrid search. So Redis does actually support full text vector and hybrid search, which combines all of those. So we can use a hybrid search to search Redis based off those memories and then retrieve them, just the relevant ones, and send them to the LM. Now, that step of this is like, that's nice. We're only retrieving the relevant memories. In this implementation, when we store the memory, we're actually just going to restore every single message that is ever, every response that's happened with this user. And so that's a very naive storage mechanism, but we compensate for that naive storage mechanism by having this nice search in front, right? So it's an interesting combination here where we're being very naive about what we store, but we're being, more clever about what we retrieve. So we're going to use the built-in context provider. So it's built into Agent Framework in the Redis module. And when we set that up, we're going to point at our local Redis. We're going to, give it a particular index that it's going to use and prefix. And we're going to give it the information about the user, all right? Because remember, memory is user specific. It's about personalizing for this certain user. So we actually need to pass in a unique user ID, and you got to make sure that this user ID is constant to that user over time. So typically you'd have like a login, maybe with Entra. So if you were doing like Microsoft Entra, the user ID would be the Entra identifier, the OID of Entra, right? So just depending on how you're building how you're building user login, that's going to determine your user ID. And then we're going to pass that memory provider as a context provider. So this is another kind of context provider that we can give to agents. So let's go ahead and check out that example. So agent memory Redis, and here we go. So that's what we were just showing, that we have all that set up there using the built-in Redis context provider. Okay, we're going to run that. And we're going to show, in this case, I'm just saying remember, right? Generally, in this case, the Redis one is going to store every single thing. So we don't have to queue it with remember, but a lot of times when you're using memory systems that are dynamically deciding what to store, it helps to say remember, because then the LM's really like, oh, okay, you told me to remember, I'm going to remember that, right? I do this all the time with like M365 Copilot and GitHub Copilot. If I really wanted to remember, I will straight up tell it, hey, remember this, right? But for the Redis, the way the Redis provider is implemented, it will remember everything. Right? But the agent says, oh, okay, got it, I'll remember. Of course, it's going to remember everything. We're calling a preference. What's my favorite city? Your favorite city is Tokyo. So we can see here that it was able to recall that memory. So it was able to search and find that relevant memory. And then we ask what's weather in Paris. And then we see what city did I just ask about? What was the weather? And it remembers that as well. So let's go ahead and check out what the Redis database looks like now. And here you can see a bunch of memories. So this time it stored a memory for every message in the thread. So let's see, when I do the values, what you can see is that this memory here is just a single message in the thread, right? So we are storing these memories in a very naive way, which is just one message, one row in our Redis per message. But it's surprisingly effective because we are filtering when we retrieve memories. So I don't think I would personally use this approach for a production agent because I don't really like the way that it's storing every single message, but it's interesting to see that it actually does work. So, it's cool to see that works. It wouldn't be my preference. So, let's see something a little different. So the big, the fancier approach to memory is this package called Mem0. It is an open source package as well as a hosted service, and it's one of the well-known memory solutions out there for agents. They've been around for a while. So here, when the agent gets input, it's going to search the memories and it's going to use the connected database. Now, this database can be anything. By default, it's Quadrant, just a local in-memory quadrant, but you can connect it to Azure AI Search. You can connect it to Postgres. You can connect it to lots of different databases, right? So it provides an abstraction layer on top of databases, right? So happens to be using Quadrant in memory by default. So I didn't change that, but we could totally point it at other databases as well. It's an abstraction layer on top of that, right? And now what's really interesting is that when we get the response, it's going to use an LLM in order to decide, hey, is this a new memory? Is it an updated memory? Or does it mean we need to delete a memory, right? So it's going to say like, okay, based off this response, I'm going to recommend that we add, update, or delete particular memories, right? So this is the part that's really interesting and clever. And just to break down this part more, right? So we get the response, and then Mem0 says, hey, LLM, you're going to review this response and suggest related memories, right? So it actually does a retrieval at this point to say, hey, what existing memories are similar to this response, right? So it does this retrieval step here and says, oh, okay, like, the new memories, first it's going to extract potential new memories. Okay, so we extract potential new memories, like the user hates snow, they live in New York, and they love the sun. All right, and then we search the database based off of those potential new memories, find any related old memories. So in this case, lives in California, loves the sun. And then it makes another call to an LLM that says, hey, compare the potential new memories to the old memories and recommend action, right? So for each potential new memory, for hate snow, say, oh, okay, that's a new memory we're going to add. Lives in New York, that's an update to an existing memory, because we went from lives in Seattle, live in New York, and we can't, or live in New York, live in Seattle, live in New York, and you can't live in both places. And then loves the sun, that is a redundant memory, so we don't have to do anything with it, right? So you can see this is a multi-step process. It's a really interesting process, and it results in memories that are kept up to date, and only are storing what they need to store in order to be really relevant. So then it applies those actions to the database, and so then we have the updated memories. Right now we know that the user lives in New York, loves the sun, and hates snow. So how do we actually use this? This is another built-in memory provider to Agent Framework, so we can import it from the Mem0 module. And, we're going to set it up, and it does take a little bit of setup, which we'll see, because we have to specify our LLM, our embedding model, and if we wanted to override database, we would specify that as well. So let's check that out. All right, so that's agent memory Mem0. So there's quite a bit of configuration up here. So first we have to set up our LLM connection. So we have to do that separately from how we did agent, because we're configuring Mem0. But we can point it at many different LLMs. So in this case, if it's Azure, we can point it at Azure. If it's GitHub models, we can point it at GitHub models. This was code I actually added this morning. So if you don't see it, you're going to need to run git pull in your code space, because I just set it up, and I did a test and it seemed to work. And then OpenAI, it's just got built-in support for that based on environment variables, right? And you could point at other LLMs as right. So Mem0, it's an abstraction layer. It supports many different model providers. And I didn't customize the database in this case, but if you did want to point at a different database like Postgres or AI Search, you could do that in your configuration as well. So we set up that whole Mem0 client and configuration. We pass in our user ID, And then to the agent, we pass in that mem0 provider here as a context provider. And the agent's going to make sure it runs that context provider before each interaction and after each interaction. So then let's go ahead and try it out. Okay, so we're going to run agent memory mem0.py. I see a question. Are memories like single data? If you hate the sun and then you love the sun, will it store the reason or update the data? Well, if it sees a previous memory that says you hate the sun and it sees a new memory saying that you love the sun, it's in this case, the LLM's probably going to say, well, this user has changed their preference, right? They now love the sun. So it's not going to store the reason. It's just going to say like, well, it seems like the user has changed their preference, right? And this is all just how mem0, implements the system prompt that it sends to the LLM when it's deciding reasoning about memories. You could come up with your own memory system, or override how it does that decision making process. But I think it's quite clever the way it does it. Okay. So it's doing, we're teaching it things. Remember my favorite city. What's my favorite city? Your favorite city is Tokyo. What's the weather in my favorite city? Your favorite city, blah, blah, blah. And then here at the very end, just to show what's in mem0, I got all the memories for the user. And you can see that what mem0 decided to store was like literally these values in the database: prefers Celsius, asked about the weather in their favorite city. Doesn't seem like the most useful memory, but it's there. And then favorite city is Tokyo, right? So those are the exact memories, the exact rows in the database that it decided to store based off this conversation. It's really interesting to see what memory systems will choose to store. I think it's very different than what we as humans choose to store when we're storing memories, because sometimes it's like, oh, that really is not important at all. But then sometimes, it gets it right? Like these, favorite city and prefer Celsius, those are very relevant things. Like, imagine with a coding agent, you really wanted to know like, oh, this user prefers Python and they prefer PyTest and, they hate unit tests, right? That's the kind of thing you really want your coding agent to remember. And be able to store for the future. Oh, who doesn't love the sun? My partner hates the sun. He wants to move to Seattle because they don't have the sun. So it is irrelevant. It is something relevant that, memory systems need to remember. Might be the only one. Vampires. So talking about coding agents, an article I found really interesting was how GitHub Copilot implements their memory system. And the engineering team wrote this whole blog post about how the new GitHub Copilot memory feature works. So definitely recommend checking out that blog post, because it's just really, really interesting to see. And also to see about how they decide when to make a memory obsolete. They actually tie each memory to citations, like to line numbers in the source code, so that they can verify whether that source code still exists. So that's a super interesting way of seeing whether a memory should be obsoleted, right? Very specific to coding agent memory, but especially repo specific memory. But I thought it was really interesting. So definitely check out that article to see how they implemented that. Okay, so I see some great questions about memory. Let's bring those to office hours and move on to knowledge, because we still have a lot to cover today, actually. Probably have too many things to cover. So let's talk about knowledge retrieval, right? Now, the interesting thing here is we've already done lots of knowledge retrieval using tools, but there might be some situations where you're building agents that should always be retrieving knowledge before even going to the tools. If you're building very domain-specific agents, where you always need to retrieve knowledge, then you can actually implement a context provider in order to always retrieve knowledge before going to the tools, right? So we're going to look at how we can do that, but just keep in mind that you may not need to do this. You may simply implement knowledge retrieval via tools. This is just an option if you're building a very domain-specific agent that always needs to retrieve particular kinds of knowledge. And it's just another kind of context, right? Instead of the user-specific context, we're grabbing this domain-specific context. So the general idea is that there's this base context provider, and we subclass that so that before an agent runs, it gets the query and then adds some more information to the conversation. That's generally how we provide context. Is we get the current messages, we decide what context we're gonna grab based off of them, and then we can add additional information to the conversation if there's anything useful, right? So my first example here is with SQLite. So I have like a really basic SQLite database that just has a bunch of like outdoor gear in it. And then I have this basic SQLite knowledge provider that implements the before run. And in the before run, we get the user's question. We use that to search. And if we get back results, then we add a message to the conversation that has the results. So let me go ahead and run this. And this is also the same way we implement memory. They're both different kinds of context providers. So if you were going to implement your own custom memory, you would also be making a subclass of a context provider. And it's just something that runs before the agent itself, continues running. All right, so it is, and here you can see we pass it in once again as a context provider, right? So the user says, oh, I'm going hiking. What boots and poles do you recommend? And the SQLite database found 3 matching products and then gives that to the agent, and the agent replies, right? Do you have any surfboards? And it didn't find any matching products. So the agent says, sorry, I don't have information, right? And so once again, just want to clarify, you could also build this as a tool, right? Instead of a context provider, you could build it as a tool and say, hey, tools equals search SQLite database. The difference is that a context provider is always run, whereas a tool is run only sometimes, right? And there might be situations where you want a context provider to always be run. And that's going to be your decision-making process for, is it going to be a context provider or is it going to be a tool? Now let's talk about retrieval. We talked a lot about vector and search today, right? So we get some user input, right? The best way to do a search is with what we call hybrid search, where we take that user input, we use it to do a keyword search, we use it to do a vector search, we get back results for, matching the keywords and also just semantically similar results using vectors. Then we combine those together using this reciprocal rank fusion algorithm that merges the results. And now we get the best of both worlds, right? So I've implemented a hybrid search using Postgres. So that's agent knowledge Postgres. And, Postgres has the ability to do both full text and vector search. So you can see here, I've got a vector search query, I've got a keyword search query, and then I merge those results together. We're not going to go deep into hybrid search today. We've definitely talked about that in past sessions, but this is just to say, if you are implementing search, you want to think about the best practices in order to get the best retrieval. And hybrid search is one of those best practices so that you can both match keywords, but also match semantically similar things when the keywords don't match, right? Okay, so we got back some good results there. Now, another thing you want to keep in mind is that if you're passing in a whole conversation, and we are in this case because this context provider receives the whole conversation, you don't want to just pass in the most recent user message. What you actually want to do as a best practice is to rewrite this conversation into a optimal search query based off the whole conversation. And so then you're going to do this query writing step and use that to search the knowledge store. So I have another example here, which implements that using Postgres. And that's going to add in an additional LLM call, right? So, we're adding more steps here. And once again, if you implemented this as a tool, the LLM would just kind of naturally do that query writing. So if you're implementing this, like search Postgres as a tool, you don't even have to think about the query writing because the LLM will naturally do that when it's deciding on the query. This is just something you have to implement if you're implementing as a context provider, right? So you can see that it did a little query rewrite into something better based off the user's thing. And so that way it gets better results from the conversation. Now, if we want to get really fancy, I just wanted to show off the amazing knowledge base feature from Azure AI Search, which has all of this built in. So it's got query writing, it's got hybrid search, it's got the ability to search from multiple sources and run your query in parallel across multiple searches. It's got this optional reflection step where it does an iterative retrieval. So it has all this stuff built in, and it's a really nice production solution if you need this sort of knowledge provider that, does all of this for you. And it is, in fact, built into Agent Framework. That's the other reason I wanted to show it, because it is actually built into Agent Framework. Now, this does require you to set up the AI search database knowledge base, so it won't work in GitHub code spaces. I've got one that I've set up on my Azure account, but I did want to mention it because if you really are using a context provider instead of a tool, then you really want to have a really good setup. And so I think the AI search integration is a great integration here, where you only have to 5 lines of code pointed at your knowledge base, and it's going to do all that fancy stuff for you. But this won't work unless you actually have it set up. So you can see I have one set up here, and that's why it's able to pull from there. Okay. All right. I know I'm blasting through things because we only have 10 minutes left, but takeaways for knowledge provider, right? I just want to keep emphasizing that you can totally get knowledge from your tools as well. Everything we showed there, searching, Postgres, AI search, those could all be done via tools. The difference here is that a context provider is always run and a tool is sometimes run. Okay, so you just have to decide for your scenario, do I need to always retrieve this context, or is this something I want to empower the agent to decide whether to retrieve this context? All right, you have the power to decide that. You've got the option. You can do context providers or you can do tools. All right, we've got a few minutes left to talk about context management, right? We've talked about all these different forms of context, and it's like, now we're getting all this context. Can we fit it all? Can we send all this context at an LM? So every LM has a context window, which is the amount of input tokens that it can process at a given time. And when LMs first came out, their context windows were really tiny. They were 4,000, 8,000, 12,000. And we were barely able to fit, even a multi-turn conversation in there, right? These days, our context windows are more around 128,000 to even 1 million. And so they are much bigger. So we're able to have these longer conversations with more context, point them at our entire 300-page, gamer's manual or whatever, right? But it is still finite, right? It is still limited. And the other issue is that even if we are able to fit all the context inside a context window, the LLM quality, the answer quality goes down as the context window goes up, right? There's a lot of research about this. I linked to some of the good research here, but generally, as you send more context to an LLM, it's going to miss some details, right? Especially if there's a lot of distracting details in there that aren't relevant or old information. So you really ideally are only sending relevant context to the LLM, right? The better you can be about filtering down to only the relevant context, the much better responses you're going to get. Also, it's cost, right? If you send 1 million tokens to the model, you are paying for 1 million tokens, and those tokens generally aren't free. They're free today because they're running in GitHub models, but also we're limited on the number of tokens we can send there. So, in production, you're going to be spending more the more tokens you spend. Now, what can we do, right? So one technique is context compaction. If you've used GitHub Copilot, you've probably seen this where it says, compacting conversation, right? This is a very common technique in agents, is that when they realize that you're getting too close to the context window of a particular LM, they will compact that conversation into a smaller amount, right? So here, if the context window is 200K and we're at 75% of that context window, then we send that entire conversation to an LM, tell it to summarize, and then that summary, takes up much less space, right? And you can just keep doing this, and just keep going and having what looks like an infinitely long conversation, because really that conversation keeps getting compacted into summaries, right? But when you implement this, you do have to decide how often you're going to summarize, what is the most important to summarize, and do you actually store the originals anywhere for later, or you just discard them, right? So the way we're going to implement summarization for agent framework is we're going to use middleware. We talked about middleware yesterday, and I realized in retrospect that I did not do a good job introducing the concept of middleware. Generally, the idea of middleware for a framework is that it makes the middleware more flexible. The middleware gives us a way to intercept stages of the framework and do things at different points of the framework, right? So for the agent framework, it lets us intercept as messages are going through and decide that we're going to do something else, right? So in this case, we're going to intercept our agent and say, oh, our context window, as the token's gone over the threshold, okay, then we're going to go and ask an LM to summarize. And then we're going to replace the messages of this agent with this summary, right? We're actually going to override it. And then, the agent's going to proceed with this new summarized message. And then we're just going to keep track of our number of tokens, right? So in this case, this middleware is going to use an LM in order to summarize. So let's look at this summarization middleware here. So here's our summarization middleware. Okay, so in this case, we're subclassing agent middleware, and we're keeping track of how many tokens we're currently using and what our token threshold is. So we're saying like, oh, our token threshold is like, in this case, we're setting it really low just so we can demonstrate. So just 1,000 tokens. And then in this process method, and this is called each time an agent runs, we're going to check to see if we're over our token threshold. We're going to get all the messages in memory. We're going to send those to an LLM. We're going to replace our memory with this summary message instead. We're going to reset the amount of tokens, and then we're going to actually proceed with the agent, right? So all of this happens before the agent run. Then we'll proceed with the agent. And then after the agent runs, we're going to just remember what the current token size of our conversation is. So that is the summarization middleware. And down here, when we set up the agent, we pass that in as middleware. All right. And we've set the token threshold really, really low here because we want to demonstrate it. Normally, you would set the token threshold to like some percentage of the context window, like maybe 75% of, and you'd have to know the context window size for the LLM that you're using to make sure that you're adapting correctly. So here, we're setting it really low. Oh, so we actually even set it to 500, super low. Okay. So each time when the agent is called, each time we call agent with agent.run, it's going to check. So in this case, it says, token usage exceeds the threshold. We're going to summarize 4 history messages. We get back this summary, and we replace the entire conversation history with this summary message instead. And then we can see that's compacted. And so this takes time. So that's why when you're ever using something like GitHub Copilot and you see compacting conversation, it takes some amount of time because it's sending a huge amount of history to an LLM and asking for a summary. So this one's doing it quite a bit. But with these larger models, you can actually, you don't have to do it this often. Okay, so that is summarization middleware. So this is one of the first kinds of middleware that you might consider adding if you're building this sort of, user-facing agent. Now, one other technique is to reduce context using sub-agents, right? So you could have an agent that is using LLM and has access to a bunch of files, and every time it calls a tool, it gets back the response from those tools, right? So, and these responses could be quite large, right? Like I've got an agent that searches through a code base and it'll grab entire files. And some of those files are like 10,000 lines long, right? So all of those tool call results add to the agent's context and can become, the context grows with each tool call result, right? So that can mean that you're dealing with a very large context window over time. A different approach is to have a coordinator agent that's in charge of calling sub agents, and that sub agent is just going to return a summary of those tool calls, right? So we're just sticking an agent on top, and that agent is asking it to do something, getting back the summary and sending it, right? And the idea here is that if this agent's job is to do something like to answer a question, it can do a better job based off of a summary than of having just all that straight context set at it, right? And it's just, and as soon as we have like multiple agents, it can be really helpful. So this looks similar. It's basically like the supervisor agent that we showed last time, but we're just using it in order to reduce context. So here we've got a coordinator agent that answers questions about code, and you have this research sub agent. So this is a very common pattern with research, because research can get these huge files, and it can really overwhelm the main agent if you send it this huge file. So general best practice is to use a sub agent for doing research and then returning back the summary to the agent that actually has to answer the question, so that they can answer the questions based on the summary instead of being like super overwhelmed by potentially distracting context, right? And I did an example here, comparing the single agent versus coordinator with sub agent. And what you see is the coordinator agent got passed way less tokens in the end, only 1,000 versus 8,000, and was still able to answer the question accurately based off of that, right? So I think the total number of tokens was actually pretty much the same across there, but the coordinator agent got way less, and so was able to give a more focused response. So this is something to consider and something you want to evaluate to see whether it's a useful technique for what you're doing. But it is very common, especially with research. So here we have examples of when to use subagents, like really when tools return large outputs. And that main agent might have multiple responsibilities besides just researching, right? So this is very common with code agents. But there's many times where you don't want to use subagents. Okay, all right. We're at the final slide. I'm sure there's lots of questions because we had a jam-packed session and I didn't get to answer all the great questions I saw in the chat. But the good news is that we do have office hours right now. So what we're going to do is head over to Discord for the office hours. So come there and bring your questions. And we'll also record those office hours and post them afterwards if you miss it. And you can find them all in the resources thread. And I even here's the recording from yesterday. And I even post the questions that come up in office hours too. And I also even for each presentation, I do a write-up now. This is all LLM generated, but if you do want to recap what we review for every session, there will also be this write-up of the slides and what we talked about. And I also even added the office hour questions to the bottom of this. So we're trying to give you as many resources as we can in order to, learn from everything we're sharing here. And we'll just, I'll just be putting everything in this resources thread. So definitely bookmark this resources thread. But also come to our office hours right now. And if you don't come, we hope to see you tomorrow for monitoring and evaluating agents. All right. Thank you, everyone. Hope to see you soon in the Discord.
Thank you. Thank you, Pamela. Thank you all for joining. We are always looking to improve our sessions and our experience. So if you have any feedback for us, we would love to hear your opinion. You can find the survey in the chat or on the screen.